Okay, we're going to look at solving a quadratic with square roots. So one thing that this is actually a quadratic right here, right? I know it's a quadratic because of that x squared term. That's what makes it a quadratic. This technique, solving with square roots, is a great and efficient technique to use because you can get through it algebraically very fast. However, you cannot always use it. You can only use it in certain contexts. You need to have either an x squared or an x plus or minus some number squared. And that's like the only place you can have your x. If it's fully in standard form, like if you have something like y equals ax squared plus bx plus c, or like with actual numbers, 2x squared minus 5x plus 9, you would not be able to use this technique. So you have to have just an x squared. Once we have just an x term, it won't work. If that wasn't here, I could definitely use it. If it was 2x squared plus 9, it would work. But when I have an x squared and an x term in the same equation, I cannot use this technique. Okay. All right. So let's look at one where we can use this technique. This is problem number 5 from, let's see, I believe it's from 4-3. We can definitely do this because we have an x squared, and that's the only place that we have the x. So what we want to do is we want to isolate that. We want to get that by itself. So you have to ask yourself, what's the math happening between that 6 and that x squared? It's multiplication. So we'll undo that multiplication with division. So we'll go ahead and divide that out. Now, these numbers aren't too bad, but most people want to use a calculator for division at this point, and that's okay. So we'll do 504, divide that by 6, and we're going to get 84. All right, so we are now have x squared equals 84, and I'm just going to rewrite it so it's very clear what I'm doing to both sides, because this now has the x squared isolated, but my solution is going to be x equals a number, so I have to undo that square. In order to undo the square, I'm going to do the square root. So I have to do that on both sides, just like I had to divide 6 on both sides. But here's the other part that's really important. Whenever you introduce the square root, if you put it into the equation, you have to account for both roots. You need the plus or minus. That is non-negotiable. You have to have that. You have to account for the potential second answer. Now, I didn't write it over here on the left. I was being kind of lazy, but that's because I knew it's going to cancel out. It's going to go away. So if the plus or minus was there or not, it's gone on the next line. I've got now x is equal to the plus or minus square root of 84. Now, this is technically the correct answer. We've got x isolated. It's equal to just a number. The number is irrational. It's in a square root symbol. But let's find out if it's a perfect square. I don't think it is. But here's how I know. I type it into the calculator, and I get this repeating decimal. Okay, so that is now my answer. And this is correct. It's mathematically accurate. My answer is either about a positive of about 9.2, or if I do the negative square root, negative goes on the outside, by the way. If you put it on the inside, it won't work. All right, it's either about 9.2 or negative 9.2. And those are my two approximate answers, but typically we're going to give our answers in simplest radical form. And that's what I'm going to do here. I'm going to simplify the radical. Now, when you simplify the radical, you start looking at your perfect squares. And those are the whole numbers squared. So I'll write out a list fairly quickly here. 1, 4, 9, 16, 25, 36. I hope I'm not skipping anyone because I'm doing fast. 49, 64, 81. Okay, well, at that point, we've actually gotten as big as the number, so we don't need more. These come from, if you don't recall, my whole number is squared. 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4. These are all perfect squares. If I do the square root of any of them, all right, square root of 36, I'm going to get a whole number. I need to know if any of these perfect squares go in here. But actually, the first two I don't care about. Dividing by 0, you can't do. Dividing by 1 is not going to change the value. So I just start with 4. And I do 84 divided by 4. 104 goes into there. It does. It works out nicely. 84 goes in, or 4 goes in there perfectly, and this is 21. And 21, I know my factors are 7 and 3, so no perfect squares go into 21. So here, just a quick fact that you need to know, 4 times 21 is 84. That's what we're going to use. And the reason that we're going to use that is because this number is a perfect square. It's on our list. So I can rewrite this out, but instead of 84, it is going to be 4 times 21. That is a multiplication problem underneath the radical, and one of the properties that we studied earlier in the chapter is that we can now split it up into two separate radicals. This is why I did this, because I wanted to pull out the perfect square factor that goes into 84, the number that is a perfect square that can evenly divide into 84. So that becomes 2. The square root of 4 is 2. And then I have the square root of 21 there. Plus or minus 2 times the square root of 21. This is my final answer. Okay, so I wanted to show you that square root of 84 that we did earlier, the square root of 84. It is the same as this, 2 times the square root of 21. Same decimal equivalent, it's just this is simplified. If you were to mark this on your test as your final answer, it would not be wrong, but it would not be full credit because it's not simplified. That's the full credit answer. Okay, and if you see the directions saying exact, this is what we want for exact. Just for fun, I'll put it on here. If you did need the approximate, which sometimes it does ask for, this is when you do type it into the calculator. So that's this decimal right here. We typically go to 2 decimal places, so I'd make that 9.17. So the approximate answer would be x is about, I already forgot the number, 9.17, plus or minus 9.17. This is exact, with the radical symbol in simplest form. That's the approximate when you type it into the calculator and you get the decimal. So sometimes you'll see the directions say no decimals. That means they want it in exact form. Hope that's helpful. Message me anytime with questions.